You might also want to look at network traffic to do debugging. Wireshark makes it pretty easy to look at TCP streams. And let me try to pull up a TCP stream here. Let's just do HTTP. I've got a million frames in my capture here. Let me just stop that and restart the capture so I'm not dealing with so many packets. Let me find a good TCP conversation to listen to here. Actually, let me refresh so I get some more packets in. Okay, if I can find a good TCP conversation here, let me look. Okay, here's one. I can follow the TCP stream, that is the conversation between the web browser and the server. This is pretty much just like a telnet conversation, if you're familiar with that, just characters over TCP. I can see that red is the client, so the client is saying get whatever, all these HTTP headers, and then this blue is the response from the server. And you can use this for debugging. I can tell just from this that my client is doing keep alive because it's got multiple requests in a single TCP stream. Yes?
Can you actually recreate what someone else is viewing? If they're looking at a web page, you can then pull it up.
I'm sure that there are programs that will do that. DSniff does include a program called WebSpy, and all that does is takes the URLs out of the network and then plugs them into your browser. So it's kind of similar, but it's not the same thing. So you can just look at the same web pages that they're looking at. But I'm not aware of a program, there probably are some, but I'm not aware of a program that will actually... Another specialized sniffer that you might want to use, that's pretty neat, is called DriftNet. I wrote EtherPeg on here, but I meant to write DriftNet. And here's what DriftNet does. I'm going to run DriftNet with the I switch on WLAN O and add the -A switch. Oops. And DriftNet is going to sniff the network traffic and look for any kind of image file, GIF or JPEG. It actually doesn't capture pings, PNG files, but let me reload a web page here with some images. Okay, we're reloading. And there it goes. And let's see if DriftNet saved those images. Oh, get to my thing here. This one. And it did. And let's see what those images look like. Okay. And yep, these are the images from that Flickr page. I've shown you these specialized sniffers, URL Snarf and DriftNet, but Wireshark can actually do these things itself also. It can find a list of URLs that are being visited or dump image information just as easily as these specialized sniffers do. So let me find some HTTP traffic. I'm going to filter on HTTP, and we want to get a list of URLs. So let's look at these GET requests, and I want to make it filter on HTTP GET. So I can open up the HTTP info in the packet info window, and let's expand this here. I can click on request method GET and then right click and apply as filter selected. It's going to show me only those HTTP GET requests, and these are as good as having a list of the URLs that are being visited, as you can see there. if I wanted to dump images, what I could do is let's look at HTTP traffic again. I'm going to look for a server response that contains an image, and then we can apply a filter based on the packet info. Okay, this is one. You can see because Wireshark is telling us that it contains a GIF image. I can come down here to the packet info, right here where it says CompuServe GIF. I can just apply this as a filter. We're actually looking into the application layer of the packet. Okay, and it pulls up all the GIFs that have come across the network. There's also a JPEG. I think that's a JFIF. Yeah. And then we get all the JPEGs. So if I wanted to save, say, this one to a file, let's see. I could just right-click on the JPEG part, do export selected packet bytes. Let's just call it image.jpg. And let's see what image we got here. It's not quite as easy as DriftNet, but you can get the same thing accomplished. It was image.jpg. Yep, we got ourselves an image. Let's get back to our presentation here. Well, another good reason to explore network traffic with a sniffer like Wireshark is that you can learn a lot. Seeing these higher level packets inside lower level packets, just like in the diagram, but seeing it in Wireshark, I think is kind of instructive and helps you learn to actually see what the network traffic is. You can also look at network traffic to learn about and detect intrusions on your network. If you've got a computer on your network that has spyware installed or some other kind of rootkit or some kind of malware, it's probably connecting to some other host on the network, on the internet. And you could detect that by looking at the packet sniff dump. You might also want to look at network traffic to do security evaluation. You would want to make sure that your application is actually encrypting things. You wouldn't want to see your password show up in the TCP stream, for example, but some applications may do that. Okay, so far what we've done has been passive network packet sniffing. But there's another way to gather information about the network, and that's through active network probing. And that's where we actively send packets to a host or a range of hosts to discover hosts, services, and network characteristics. Well, we might do this for security testing to see what kind of services are open on the network, and we might also just be figuring out how the network is set up. I've got a little picture here of a radar installation, and it sends a little ping packet out, and it hits the airplane, and then by measuring the response time, we can figure out how far away the airplane is. Well, we can do a similar thing on the network by using probably the most well-known network probing tool, and that's ping. And I can just ping any host. And it sends a packet out, and then that host sends us a return packet, and it tells us the response time. The granddaddy of ping is Nmap, and let me get that fired up. I actually use an Nmap front end called ZenMap, and let me get that running here. It wants to be root also because it sends out some strange packet.